So we learned how system will perform pointer arithmetic operation. Clear? And coming back to the array notation and pointer notation to access array elements. Clear? Now look, this is our array notation and this is our pointer notation. And look, in this array notation, the ARR is array name and I is index. So ARR means this one is a pointer and index means this one is an integer. Clear? Now coming to this pointer notation, this is our pointer notation. So in this particular notation we use ARR plus I. That means this is our pointer and this is our integer. So when we perform addition in between pointer and integer, at that time what we will get? We will get another pointer as result. Clear? And now we want to access the element from this particular address or pointer. Because of that we need to use the indirection operator here. Clear? So that is how pointer notation and array notation work in case of array to access each element of array. Clear? So let's take an example. Let's say we declare integer ARR 5. Now in memory this is the memory allocated to this particular array. The base address is 2000, so 2003, 4, 2008, 2012, 2016, and then the logical part, that is ARR, and then 2000, it will point this particular location, the address of ARR again 2000. Now coming to the index, this is 0th position, 0 index, 1 index, 2 index, then 3 index, and then 4 index. What will be the initial value? Value will be garbage, 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 garbage. All the elements are of garbage type. Now how we can access this particular element, the element of the first element from the array? We can use either array notation or we can use pointer notation. Now with the help of array notation, what will be the notation here? The notation will be ARR, then within subscript operator index. What will be the index here? Index is 0. Now for array notation, this one is the instruction. Now for pointer notation, what will be the instruction? The instruction will be ARR, that is our array name, plus 0 is our index. After that the indirection operator we need to use. Why? Because with the help of this pointer arithmetic, we will reach to this particular address. After this address we need to enter inside the block from where we will get the value of this particular element. Clear? Now coming to the next index, in case of pointer notation, what will be the notation? Notation will be ARR 1. In case of second and third element, the notation will be ARR 2. In case of fourth element, the notation will be 3. In case of fifth element, the notation will be ARR 4. So all these are array notation. Clear? Now coming to the pointer notation of each element. So for this second element, the notation will be ARR plus 1 indirection operator. For the third element, the pointer notation will be ARR plus 2 indirection operation. For fourth element, the notation will be ARR plus 3 then indirection operation. For fifth element, the pointer notation will be ARR plus 4 then indirection operation. So all these are pointer notation. Clear? Now, which one is comfortable for us? For us, for a programmer, array notation is comfortable, but system work with pointer notation. That means whenever we use array notation, at that time system internally convert it into pointer notation. After that, system access the element from given location. Clear? That means pointer notation used by the system clear. Now what happens if we use pointer notation? If the programmer already use this pointer notation to access array elements, at that time system don't need to perform any conversion operation, so the execution will become faster in such scenario. But in case of array notation, system internally take the array notation and convert it into pointer notation. That means here for this conversion, system needs some extra time. That means the execution time will increase when we use array notation. Clear? So in the point of view, from point of view of program execution, array notation is useful. Clear? Or array notation is beneficiary for use. But for comfortable level, from comfortable level, array notation is easier. Clear? So that is how we can access all the elements from an array with the help of array notation as well as with the help of pointer notation, and both of these notations are equivalent. Any one of these two notation we can use, or we can use combination of array notation as well as pointer notation also. Clear? Now how we can assign values to all these array element or all these array blocks? How? With the help of this instruction also, with the help of array notation also we can do it, or with the help of pointer notation also we can do it. So let's take some example and see how system will do. Let's say we are assigning 10 in the location 1. Now here the instruction is we use the notation is array notation. So what system will do? System will take the value 10 and it will store in the location identified by index 1. So here the value will update it to 10. Now let's say we are using ARR 4, then indirection operation, and we are assigning 20 here. Now how system will perform this thing? Now look, this particular instruction is equivalent to ARR 4 and then 20. That means where system will store the value 20, system will store the value 20 in the fourth index location, fourth index block, or the block that identified by the index 4 in the array. So which block it is? This is the block. So here system will store the value 20. Now coming to this pointer notation, this is here we convert the pointer notation into array notation. After that we find out the location and then store the value 20 at that particular location. But without conversion also we can do it. How? Look, here the instruction was ARR plus 4 asterisk equal to 20. Now what we need to perform first? We need to perform this particular addition operation first. So how we can do it? The content of ARR, the address stored in ARR is 2000. That means here we will get 2000 plus 4. Now look, this is a pointer and this one is an integer. 2000 is a pointer and 4 is a integer. That means here pointer arithmetic comes into the picture. So how pointer arithmetic will perform here? To perform the pointer arithmetic, system will multiply size of data with the integer value. Size of data, that means here in this case it is integer. So here it will be 4. So what we will get? We will get 2000 plus 4 multiplied by 4, that means 16. Then indirection. Now it will be 2016 indirection equal to 20. Now this is the actual instruction that given here. Now how system will store the value 20 in this particular indirection, in this particular instruction? Look, the address is 2016, that means system directly comes to this particular address 2016, and after getting the indirection operator, system enter insert this block. Clear? When we specify indirection operation with any address, at that time system automatically enter insert that particular block. Now after getting, now we get 2016 indirection operator then equal to 20. Now what happened? System first go to this particular block, this particular base address. So where this particular base address is located, this particular base address is located here. That means system automatically comes here. Now with the help of this indirection operator, system will enter inside the block. Now with the help of this indirection operator, system enters inside this particular block, and in this memory block the value 20 will store. Clear? That is how system will perform the assignment operation when we specify address in this instruction. Clear? So this is how we can assign values in array elements with the help of its index, and when we assign some value in some index or some elements in the array, at that time we can use either array notation or we can use pointer notation. By using any of these notation we can store values in array. Clear? Now let's say we give the instruction as printf %u then ARR. So what it will print? Look, here the identifier given as ARR. So what is the content of ARR? The content of ARR is 2000. That means it will print 2000 here. Clear? Now let's say we give the instruction as printf %u address of ARR. Now what it will print? It will print the address of ARR. So where is that ARR present? The ARR is this one, and the address of ARR is 2000. That means it will print the address 2000. Clear? Now look at here, both of the value that we get as output of these two particular instructions are exactly same, but logically they are different. The first one is the content of ARR, the second one is the address of ARR. What does it mean? This is the content and this is the address. Clear? Now one more thing. Let's say we give one more printf instruction, printf %u then address of ARR 0. Now what it will give us? Now look, it will give us, what does it mean? This is the first element of array. Here the index is 0. Array index is specified here that in the instruction, so it will represent the first element of the array. So what is the first element of this array? The first element is this one. So now we are using address of operator with this first element. That means system will give us the result of the base address of first element of the array. So what is the base address of this particular first element? The base address is 2000. That means here we will get 2000 again, but again this is not same as the previous one. This is value is same, but logically they are different. Clear? Now next instruction, printf %u then arr plus 0. Now here in previous case we use point array notation, but in this case we are using the pointer notation. So what it will give us? Look, the arr is this one, and the content of arr is 2000 and the plus 0, that means it will come here, and the address here is 2000. That means in this particular instruction also we will get, look at here, arr plus 0. So this one is pointer and this one is integer. So the operation is a pointer arithmetic. So we need to come up with pointer arithmetic operation. So the content of arr is 2000 plus 0 into size of data. Here the size of data is int, so here we will get 4. So it will give us 2000 again, but this address is not this one, not this one, this address is this one. Clear? So here again we will get the result is 2000. Look, in both of these three scenario we get the result 2000, the same result, but this one is different. This one is different as this one is representing this particular address, but in remaining three cases, in all remaining three cases we get the result 2000 and that representing the same element. Clear? Same element means, look here, the content of arr is 2000 and this content is nothing but this particular address itself, because this is already pointing to this particular location, and whenever system encounter any address or whenever system get any address, at that time system will automatically reach to that particular address. Clear? And after that what system need to do, it depends on the instructions. That means whenever we use arr, at that time it will give us the content of arr, and what is that? That is a address, and which address it is locating? It is locating this particular address. That means system after getting 2000 here, system automatically come to this particular base address. Now what system will do next? It depends on the instruction. Now after come here, if system encounter this indirection operator, at that time it will go inside, otherwise it will stay here itself. Clear? Now let's say one instruction arr and other one is address of arr then indirection operation. What does it mean? Which element it gives us as result? Look, in this case it will give us arr, that means the content of arr, that is 2000. So this is nothing but this one, that means we are getting this one as result. Now coming to the next part. In this part the content of arr is 2000. Sorry, it will not give us the content, it will give us the base address of arr. Now what is the base address of arr? The base address of arr is 2000. So here we will get 2000. Now system gets an address, and that address is nothing but this one. So system wait here. How long it will wait here? Until it will not get the instruction to enter inside the block. So now system encounter the indirection operator. So whenever system encounter indirection operation, at that time what system will do? System will enter inside the block itself. So with this particular address 2000, system locating this particular address. Now system encounter this indirection operator. Now system will enter inside this block. So it will get again 2000. So here it will be 2000. Now this 2000 is again a address. So system will not wait here. System will reach to that particular address, or in memory block where this particular address is available, system will go that particular position. So from here system automatically come to this particular address. Now we are here, and in this case also we are here. That means both of these instructions gives us the same base address of same memory block. Clear? That means in this case both of these are same. Clear? But if ARR and address of ARR, in case of ARR we are getting 2000. Now this address is this one. We already discussed this thing. Now this address of ARR, it will give us this particular address 2000. Now this one is this one and this one is this one. Is both are same? No, both are not same. Even though the result is same, but still they are different. So here in this case they are not equivalent. Clear? So in these 4 different printf instruction, this one is different, and all the 3 remaining instructions gives us the same result, and that is this particular address. So ARR equivalent to this one, address of ARR 0 equivalent to this one, ARR plus 0. Clear? Now one more point we need to discuss in this class. We already know one thing, that is in case of array notation ARRI is equivalent to pointer notation ARR plus I. Clear? Now what does it defines? It means element of ith index. What does it means? This one is address of ith element in the array. The instruction given inside this parenthesis, it gives us address of ith element in the array, in array. Now after that we get indirection operator, and we already discussed that whenever system get any address, at that time system will reach to that particular memory address and wait for the next instruction. Now after getting this particular address of ith element, system will reach to the base address of the ith element. Clear? And waits there. Now when system encounter this indirection operator in ith base address, at that time system will enter inside the ith element and then get access of the element. Clear? Now this is how pointer notation and array notation works. Clear? And both are equivalent. Now what happened in case of address of operation ARRI? What does it mean? This means the address of ith element of array. Clear? The address of ith element of the array ARR. That's what it gives us by using address of operator. Now if we convert this particular notation into equivalent pointer notation, at that time what will be the notation? Now look, in this particular example, what is the address of ARR1? The address of ARR1 is this one. And how we will get this particular address? With the help of pointer notation. With the help of pointer notation, we will get this location by using simply ARR plus its index. Clear? Look here, we are using ARR plus I and then using indirection operator. That means the whatever present inside the parenthesis, it will give us the base address of the ith element, and in this case we only need the base address of the ith element. That means no need to use this indirection operator in case of address of operator present with array notation. So here the equivalent pointer notation of this array notation will be ARR plus I. Clear? Hope you understood the concept. Clear? Now let's take an example and see how system will do this thing. Again we are doing the same one. Address of ARR1. So what it will give us? It will give us the address of ARR1. ARR1 means this element means this particular block. So what is the address of this particular block? The base address of this particular block is 2004. So it will give us 2004. Now coming to the pointer notation part. In case of pointer notation, ARR is still there and the index now is 1. Now what happened? This is our pointer and the content of this pointer is 2000 plus 1. This is our integer. That means we are adding integer with some address. So what system will do? System will multiply size of data, that is 4 in this case, as the data is integer type. Now perform the operation. So here also we will get 2004. Now look, both of these instructions gives us the same thing, and that is this particular address 2004. Clear? And that is the scenario how pointer notation and array notation works together. How with the help of pointer notation and array notation we can access any elements from the array and we can perform any operation on any of the elements of any array. Clear? So that's it for today. See you soon in our next class. Thank you.